Hey there team, it's David here with the Papaya Institute, and we're going to look at some plotting. Of course we'll go to Google Colab, which is like a magical tool. I think you can just access various programming languages through the internet anywhere on any device. Big fan. First, let's get some letters, right? I used to just copy these lines or type them in mindlessly as I'm doing now, but libraries are really useful. I'm a big fan. And today we're going to particularly look at this library, the Matplotlib library, because plotting is beautifully useful. You can have the curves and models and mathematical tools that you use or that you might be exploring, and you can visualize them, right? Graphics can help you better analyze and share the things that you're looking at. So we're going to look at the sinc function, which you might run into one day if you ever do some signal processing or study electrical engineering. It's very useful for cleaning up signals, any type of signals, and getting rid of high frequency noise, for example. And it's defined as sine pi x divided by pi x. Yeah, so it's not insane, and it doesn't look too crazy when we look at it. But let's plot it, right? Now to plot it, we're going to need some x values. You'll notice that I'm shifting them here a little bit. We're not going to start at a nice integer, and we're not going to end at a nice integer. That's because the function is not very well defined at 0, so I just made that from -7.05 to 7.005 in intervals of 0.05, so that we never really touch 0. It'll be good, you'll see. Alright. So just as we defined it earlier, right? And then we'll divide by pi and x. Cool. Oh, that didn't do anything, right? Because we got to plot it. And for plotting it, we'll use plt.plot, right? The matplotlib function is just great. Always there for us. And a little plt.show, of course. Cool. Now, I think this is really a pretty function. See, it's got a nice sinusoid, cosine type shape, symmetric, but the amplitude's doing something, right? Now, plotting, again, very useful to analyze, share, study the different curves that you might be looking at. So, you just want to be able to have all the details we can in plots. The most basic one, I'd say, is just give it some color. Right? You can change the color of the curve just by adding this color argument to the plot function, right? But we can clean it up a little more. We can do some labels. The x labels and y labels are pretty explanatory, right? Just plt that y label or x label, and then you can tell it whatever you want. See? Hello for the y label, x for the x label, but I think we can do y for the y label. How about that? And of course, you might already know there's the title, because a nice graph has a nice title. There we go. Starting to look pretty professional. And if you're out in the world sharing your cool math models with friends or comparing different math models, perhaps you want to have multiple curves that you look at. So let's do that. Let's have another curve. We'll just have this be a scaled sine. Yeah? Similar to the above, but just no division by pi x. Okay? And we run it, and nothing here. Right. Making the function is not plotting the function, right? We defined y2, but now we gotta plot it. Okay. plt x comma y2. Awesome. Let's give it a color also. I'm feeling blue. Alright. Oof. A little strong, right? I think that's a little too much blue. So, just for fun, here's another thing you can do. You can add dashes to your curves, right? And the dashes take a list of numbers, and the numbers are essentially pencil down, pencil up. So I'll tell you what I mean now. 2, 5, right? So that means 2 pixels of painting, 5 pencils black. 2 pixels of painting, 5 pixels blank, right? And so on. That's what the 2, 5 means. You can do all kinds of funny patterns if you add more numbers. And this really helps you when you're plotting multiple curves, right? I think the blue's still a little strong, so I'll introduce you to yet another tool, the alpha parameter, and this is opaqueness. Alpha of 1 is just full opaque, as the color is now, and alpha of 0 means fully transparent, so you would see nothing. So here, let's do a 0.5, half opaque. The lower the alpha, the higher the transparency, so you can see that this is more transparent. Awesome. Very good. And then, of course, if we were to set it to like 1, it would be back to where it was before. There you go. But I like that 0.5. I like that soft blue. I think there's something nice about it. Cool. And then, of course, if you have multiple curves, perhaps you want to have them labeled, right? We can do that with plt.legend. So you just have a list of strings, and the strings will be the names in the order of the plotting, right? So we plotted the sinc function first, and then we plotted the sine function. So we'll just have that there, right? So sinc function, cool, and then in a separate item, the sine function. And it makes a nice little label. Now this is looking professional if you ask me. Okay, what else can we do? We can also change the limits, right? So for example, you can see here that we fed to it -7, 7. So that's more or less the x that we get. And we're seeing -1 to 1 more or less, because those are the y values that come out of that x, right? So you can actually change that. You can change the x limits, and then you just input the two numbers you want here. So let's make them -6 to 6, right? And we'll watch this change happen live. Okay, there we go. And we'll do something similar for the y values, just for educational purposes. And let's do -1.5 to 1.2. Right, this is going to be a curve that is like floating vertically. Yeah, and the extra space is kind of nice. Lets you breathe a little. Very good. And now the next level is to have multiple figures, right? Python and Matplotlib will call this one figure. So if we want multiple of them, you can actually do it like this. There's a subplot function that has these figure and axis outputs. Subplots, okay? And let's say I want 4 plots, yeah, in 2 rows and 2 columns. So 2 rows, 2 columns, that's what goes in here. Cool. And then before, where we used to do things like plt.plot, right? We're actually going to do something similar. Let me show you. We're going to do axis, this output here. Uh-oh, no, don't do that. And then in brackets, we'll say which one we want, right? Because we made this argument that's going to have 2 by 2 plots. So in the axis, we can say which plot we want to plot to, which figure we want to plot to. So 0, 0 means the 0 row and the 0 column. That's the first one, right? Or top left. And we'll just go ahead and copy this stuff. Boom. Okay, and then we'll just do it again. Axis 0, 0. Dot plot. And we'll just copy the stuff. Oh, careful with those parentheses, they'll get you. Okay. Now they'll only do one, so we gotta do the other ones really quickly. We can be smooth about it. How about, let's see, there are 4 of them, so this can be the 2 and 3. Got it. Okay, so this is rows, columns, right? So how about we stay on the first row still, but we'll do the second column, right? And we'll just plot X. Right? Now we can do the second row, first column, right? That would be 1, 0. And again, we'll just plot X. Or actually, let's experiment. Let's plot X squared. How about that? And then we'll do second row, second column, right? Now we're talking bottom right. And we'll plot, what are we feeling? Let's do sine squared, right? We did sine earlier, so why not sine squared, right? Sine was in this y2 variable, right? Which again is why we love variables. We defined this once, and then we don't need to do it again. And we'll do sine, that's sine, and we'll do it squared. Sine times sine, cool. Now let's make it red. I like red. It's a nice color. Cool. And of course a little plt that show to clean it all up. And look at that. I think you can start to see how, given the data and the curves to analyze, you could really display them nicely, compare them nicely, share them with somebody, come to some new conclusions, see some funny patterns. And most of the things that you were able to do before, you can do here. So here, in the first plot, in the 0,0, top left, you can also add the legend like before, right? We'll just go ahead and steal it from over here. Some things don't translate, right? So that's where we gotta be careful. So the legend, same thing. You can just paste it on top of the axis argument. And there we have. There we go, now we have the legend. And we can also do titles. 0,0, right? Now it's a little different here. It's that title, that set text. Not the same as before, but we will survive. Sinc and sign. So then you can see that the title, and then there's something similar for the X label and the Y label, right? You can exactly copy it over. It's not just .x label or .y label. You have to do .set Y label, and we'll do it here. Well, let's call it little y. Oh, we'll go formal and use the TTLE version. There you go. And you can do it also for the X's, of course. And now one thing I always like is this extra argument that you can put at the end, just in case it gets a little bunched up. For example, you can see that the little x is kind of ugly here, right? You can't even see it. It got covered by the bottom left plot. So there's actually one more argument that you probably want to use, and this is where you use the figure argument. So you'll do figure dot tile layout parentheses, and that's just a function to essentially say, hey, make it look nice, and it looks nice. Now with these tools, you can explore and plot and compare and share your mathematical models with other people, and I think it's honestly kind of fun. So there's that. Thank you for watching, and have a great day.